Hello, and welcome to my video on the January 2019 Algebra 2 Regents question number 33. On this problem, we're asked to solve the following system equations algebraically for all values of a, b, and c. And we see the three equations with the unknowns of a, b, and c. The one thing to note here is that, well, we typically will identify each equation as 1, 2, and then 3. But the third equation here, you'll notice that the variable a is actually on the right side of the equation with the b and c variables on the left side. And that's not typical. So the first thing that we perhaps want to do, as we typically see with system equations, is to move the variable a to the other side of our equation before we start doing any operations. So we would have here negative a plus 6b plus 2c, that equals to 14. And this would be our equation number 3. So now that third equation has the variables a, b, and c on the left side, we can start looking to combine equations together to eliminate one of the variables. And in this particular system of equations, I would think that the variable a would be the easiest to eliminate because the first two equations have just positive 1a in their equations, whereas the third equation has the variable negative a. And eliminating a is going to be the simplest to get rid of first. So I will first combine together equations 1 and 3 to help eliminate that variable a. So we'd have a plus 4b plus 6c, that should equal 23. And then we would have negative a plus 6b plus 2c equals to 14. And we would just combine these equations together. And again, when we do this, the a's will cancel. We would have 10b plus 8c equals to 37. And this equation here, I'll call equation 4. So we've gotten one equation that has eliminated the variable a in it, and then we'll do this a second time by perhaps using the equations 2 and 3, combine them together to get rid of the variable a. So I'll write here a plus 2b plus c is equal to 2. And again, our equation 3 is negative a plus 6b plus 2c equals to 14. Combine these together. Again, the a's cancel. We get 8b plus 3c is equal to 16. And we'll call this equation 5. So now we have these equations 4 and 5, which we can work together to help solve for either b or c, and then we can go from there. Now, when we typically do solve for the b or the c here, again, we try to use the same method of elimination. And I think in this case, it would perhaps be easier to eliminate the variable c's because those coefficients are smaller than the coefficients for b, and we would perhaps have to do less work to get these variable c to be the same. So if you do work with the variable c on the equation 4, which we can write up here, to get the coefficients to be the same, we would perhaps want to multiply our equation 4 by the value of 3. So we would then get 30b plus 24c is equal to 37 times 3, which would be 111. And then our equation 5, to get equation 5 to have the same coefficient for c, but we'd want it perhaps to be negative, we can multiply by negative 8 so that this coefficient for c would become negative 24. And then when we combine together the two equations, the variable c would be eliminated. So then we would have, multiplying everything by negative 8, we would have negative 64b again, minus 24c is equal to 16 times negative 8, which is negative 128. And then we can combine together these two equations. When we do this, again, the variable c's will cancel and eliminate. We would, when we combine together the b terms, we'd have negative 34b. And then the right-hand side, when we add up those two numbers, we get negative 17. And then solving for b, we divide both sides by negative 34. And we would get that b is equal to 1/2. And so now we have our first of three variables, and then we can work backwards to solve for both a and c. In particular, again, just kind of go in reverse order. Knowing that b is 1/2, we can go to either equation 4 or 5, plug in 1/2 for b to solve for c. So maybe, I'll choose the equation 5 to actually accomplish that. So using equation 5, we would have, again, b is 1/2, so it'd be 8 times 1/2 plus 3c is equal to 16. So 8 times 1/2 is 4, plus 3c is equal to 16, which means that 3c has to be equal to 12, and thus the value of c would be not 3, but c should be 4. So then we would have what the value of c is equal to, and now knowing the values, what the values for both b and c should be equal to, we can go back to one of the original three equations, and looking at them, I'd perhaps choose equation 2 to help solve for the last variable a, what the variable a is. So we can write a plus 2 times b, which again, b is 1/2, plus c, which we just solved for is 4. That should equal 2. And then evaluating this, we'd have a plus 2 times 1/2, which is 1, plus 4 equals to 2, or a plus 5 equals to 2, which means that a would have to equal negative 3. So the solution to the system is that a is negative 3, b is 1/2, and c is 4. So I hope that this video helped you out with this particular problem. And good luck with all your studies. Thank you, and thank you for watching my video. Take care.